Here's a quick run through on how you use the simulator for your assignment this week. The first one you're going to be doing is determining the concentration of an acetic acid solution. The second one you're going to be doing is determining the concentration of a hypothetical weak acid solution. So we're going to click Find the Concentration, and we're going to read the instructions. And once you're ready, you're going to start your titration. So we see the Ka of the acid, we see the volume of the acid. We don't know the concentration of the acid, and so we're going to do a couple trial runs to see what that concentration might be and to try and get an appropriate curve. So we're going to leave the concentration at 0.1 moles per liter, and for our first trial run we're going to add fairly quickly. So let's say 3 milliliters at a time, and when I add fairly quickly, I don't even see the end or my inflection point. So that means in order to see the inflection, I have to increase the concentration of my NaOH. So I'm going to rerun with the same unknown concentration. And now I'm going to increase the concentration of my NaOH to, let's say, 0.3. And rerun again with 3 milliliters just as a trial run. Still not strong enough. So I'm going to rerun and I'm going to go up to 0.6, and let's try that at 3 milliliters at a time. And so let's run it. Now we have our steep inflection at approximately 30, which is right in the middle, which is nice. This is what I'm looking for. So I'm going to finish this curve. Now this curve doesn't look that great. So what I'm going to do is I'm going to make this look a lot nicer by manipulating the volume. So rerun the same curve, but now I need to make note of my inflection at the start, which lasts for about 3 milliliters, and my inflection in the middle, which starts around 25 milliliters. So now that I know I need to be slow for the first 3 and then slow down again at around 25 milliliters, I'm going to rerun this trial. So again, my concentration needs to be 0.6. I'm going to start with 0.5 milliliters, and I'm going to add a small amount to get that nice looking curve for the inflection. Now that I have that, I can increase my volume to 3 again and go until right before 25 or right around 25. And now I'm going to go back to 0.5 and get my curve, my nice steep inflection, and keep adding dropwise. And now that I'm past my curve, my inflection point, I can go back to 3 and finish off my curve. Now that I have my curve, I need to analyze this curve. So my inflection point happens at a pH of around just over 9.2, and my volume is going to be somewhere around 28 milliliters. Now we can be a little bit more precise with our data down here, and so we're going to go down to around 28 milliliters, and we should see 26.26, 6.66, and then 11.2. So what I want to do is in between those two, I want to figure out the volume. So it would be actually 28.25 milliliters that I would need to use for my stoichiometric calculation. Now I know the concentration of sodium hydroxide is 0.6 moles per liter. I know the volume of sodium hydroxide is 28.25 milliliters, and I know the volume of acetic acid was 25 milliliters. I can complete the stoich, which is what you're going to do on your lab write-up, and you're going to then put your solution in here, and hopefully you'll get a nice check mark. If you've done your stoich correctly and you put in your solution, you should get this beautiful star sticker, and you should be very proud of yourself. Screenshot this and include it in your lab report.